4 triangle similarity. Okay, so let's talk about the word similar and compare it to the word congruent, because our last unit was about congruent triangles and this lesson's about similar triangles. So with congruent, everything is the same size, same shape, everything is the same. But with similar, and I want you to add this at the top, the shapes are still congruent. It's the size that's going to be different, but we're also going to say that it's proportional. So it's got to have a similarity ratio. You've got to be blowing up all the sides by 2 or dividing all of them by 1/3, things like that. So there's 3 ways to prove triangles similar: angle, angle, side, 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 and side, angle, side. And so let's look at the difference between these 3 compared to our 5 in our last unit. So the first one we're going to look at is angle, angle. Notice we didn't have anything like that with congruencies, because we could take our triangles and blow them up proportionally and they could still have the same angle measures. You only need 2, because if 2 of them are congruent, we know the third one has to be congruent because they always have to add up to 180. So let's look here at example 1. We want to show that these 2 triangles are congruent, and by 2 triangles I mean this one here in blue and this one here in purple. So we can see that one angle is already marked congruent, but we have to find that second one. Well, we don't have parallel lines, so that's out of the question. But we do have, and we don't have vertical angles, that's out of the question. But remember, our reflexive property means that they share, and we have angle A being the same in both triangles, and so that shows that they're congruent. We have that reflexive angle, so I want you to write that down to the side, that you have that reflexive angle. And remember, reflexive means shared. And so we do have angle, angle similarity, and that squiggle means similarity. Okay, let's look at the next one. So with this one, we do see that we have some parallel lines, so let's use that to our advantage here. We could use that as a transversal and use these set of angles there in red. We could use this transversal and use these angles as being congruent. So that right there gives me enough. We don't need the vertical angles. We could have used them, but we didn't need them. So that alone shows us that we have angle, angle similarity, because we have the parallel lines which give us alternate interior angles. Okay, so that's what you have to do if you're trying to prove angle, angle similarity. Justify it by the angles, what you have. Either look for the shared angle, the reflexive angle, vertical angles, alternate interiors, all of those. Okay, so let's look at a sample problem. And before we even look at the problem, let's talk about these triangles. Do we have enough information to justify that they're similar? Yes, we have these angles being the same and these angles being the same. So that is enough justification to say these are similar. And remember, when they're similar, sides are proportional. So we have to use that to our advantage to find missing pieces. So it says a flagpole casts a shadow that is 50 feet long. At the same time, a woman sitting nearby who is 5 feet 4 inches tall casts a shadow that is 40 inches long. How tall is the flagpole to the nearest foot? Well, we can use our similarity and our proportions to figure out this. So we know that we're going to need a proportion. And so I already have all my information I need about the flagpole, okay? But with my person, it says 5 feet 4 inches, and then the shadow's in inches. So we need to convert her height into inches. So if there's 12 inches per foot, 5 feet, 60 inches plus those 4 gives me 64. And now we can cross multiply. So we have 40x. As we multiplied that, and we multiply 64 and 50, it gives us 3,200. And so if we divide, x is going to equal 80. And because we're talking about feet, we do need to convert that. No, that gives us 80 feet. That's our final answer. Sorry about that. Okay, next one we're going to look at is side, side, side similarity. Not congruency, similarity. And we said with similar figures, sides are proportional. So in order to prove this, you have to show that that all three sides are proportional. So let's look at an example here. All right, we're going to find the value of x to prove and show that these three sides are proportional. Well, I'm going to find a side that's complete, and I see here that 4 and 12 is complete. Well, I know that relationship is that the bigger triangle is 3 times bigger. So if I'm going to take my 8 and make it 3 times bigger, I now know that this side has to equal 24. And if this side over here is 18, what times 3 gives me 18? 6. So I could do a couple of things here to find x. I could set up a proportion with the 4 and 12, or I could even reduce that to 1 over 3. Or I could say, well, if I know that this right here has to equal 6, I can just solve it. Add my 1 over, x equals 7. Okay, so then let's check that and plug it in right here also. 7 plus 1, 8 times 3 is 24, so that did work. So now I can prove and say, okay, 4 over 12 reduces to a third. That one worked. 6 over 18 reduced to a third. That worked. And then we had 8 and 24 reduced to a third. And that justifies that all three sides will work. And we also found our x. Example 4 wants us to prove those, but we're going to skip that right now. We don't have to worry about that kind of question. We're going to go ahead and go to side angle side here. And so side angle side is very similar to the other one, except for your sides aren't congruent, they're proportional. So you have to prove two sides are proportional, and then you have to look for a congruent angle. So let me show you how this works. So if we look at this one here, we've got our angle, check, done. We don't have to worry about that. But we do have to check our proportion of our sides. So we want to say 24 over 18. Let's reduce that. What goes into both 24 and 18? What's the biggest number? Well, we can divide both of them by, let's see, 3. So divide both sides by 3, and we get 8 over 6. But we could even take that a step further and divide that by 2. And so we could get 4 over 3. Okay, so there's that one. Then we want to take the other one and say, well, let's do the same thing to 28 and 21. Biggest number we could divide by is 7. 28 divided by 7 is 4. 21 divided by 7 is 3. They both reduce to the same thing, so side angle side does work here. When you're trying to prove it, you have to justify and show that they both reduce to the same thing. That's important to show that when you're showing work. Okay, this one's a little different because this triangle is laying kind of on its back, if you want to think about it like that. So let's redraw these two triangles so that you can see this a little bit better. Let's redraw our big one. So the 16 is now here, the hypotenuse is 20, and the bottom is 12. And then our smaller one's facing the same direction, 9, 12, and 15. Now they both are right angles, so that covers us there. Check, we're done with the right angle part, or the angle part in general, and so we want to test and see if they're proportional. So 16 corresponds to 12, so let's set that up. What's the biggest number that goes into both 16 and 12? 4, so divide both by 4, 4 over 3. And let's take the 12 over 9. And let's divide, what's the biggest number? 3. So that gives me 4 over 3 again. So that proves and justifies that two of your sides are proportional. The angle between is congruent. So side angle side similarity does work on this one also. So again, angles have to be congruent. Sides have to be proportional. And so in order to prove and justify without me making you write a proof, you have to set up your proportions and solve or set up